Immunoglobulin E, or IgE for short, is one of the 5 classes of antibodies. It serves an important role in fighting helminth infections. There are many facts to remember about IgE, so I will give you a visual mnemonic to help you remember all the key points on exam day. Our scene takes place on a fishing boat, where marine biologists are researching a rare eel called the IgE eel. Let's focus on this eel, shall we? It's a rare species with these Y-shaped tails. Do you remember what else looks like the letter Y? That's right, antibodies. Since Y-shaped things are our recurring symbol for antibodies or immunoglobulins, this Y-shaped eel should help you remember immunoglobulin E, or IgE. Get it? IgE eel? Although IgE is the antibody present at the lowest concentration in the blood among all the other antibodies, it has specific effects that are very important in tissues. Let's explore the rest of this scene to learn more. Now, let's look at what bait the eel has been caught on. Of course, it's a worm. If you've ever gone fishing, you'd know every fisherman uses worms. This is a great symbol, since IgE or IgE eel primarily functions to attack parasitic worms, also called helminths. In fact, IgE is one of our key defense mechanisms against helminth infections. IgE can directly bind to the proteins on the surface of the worm. This bound IgE is then recognized by other immune cells like eosinophils, which arrive to kill the worm. In addition to its direct effects on the worm, IgE can activate cells to induce a local inflammatory response. It's actually high yield to know what these cells are, so let's introduce a few more symbols. See how our marine biologists are wearing baseball caps? These guys must be big baseball fans, and these baseball caps also help to keep the sun out of their eyes. Speaking of baseball, doesn't baseball remind you of basophils? That's right, these baseballs are our recurring symbol for basophils, since baseball sounds like basophils. Basophils are a type of granulocyte activated by IgE. Specifically, basophils release their granules when IgE binds. We cover basophils and their granules in another video. But for now, just know that activation by IgE causes release of histamine, which in turn causes local inflammation. The end goal is to make the local environment less friendly for the parasitic worms to live in. Next, turn your attention to the massive mastiff. Don't you know? Mastiffs make great fishing partners, since they have a knack for smelling out eels. Mastiffs also happen to be our symbol for mast cells, another type of immune cell that are activated by IgE. Get it? A mastiff for mast cell? Mast cells function similarly to basophils by releasing stuff in their granules in response to IgE binding. And these granules contain pretty much the same thing, histamine and other things. Again, this promotes an inflammatory response that makes the local environment more hostile to parasites. Now that we know IgE activates mast cells and basophils, let's dive a little into the mechanism behind their activation. Turn your attention to the IgE eels that are tied together on that string. Fishermen are always holding their catch on these strings, and this one seems to be tying a loop at the top to secure his catch. By the way, these antibody-shaped eels being tied together should help remind you of IgE cross-linking. We've already mentioned how antibody-shaped eels symbolize IgE, and cross-linking is just bringing two things together, kind of like tying the string here. All of this should remind you that activation of basophils and mast cells happen when two IgE are close together or cross-linked by an antigen. This cross-linking helps confer specificity so that mast cells or basophils only activate when foreign antigens are present. How does this work, you ask? Let me explain. I already mentioned that basophils and mast cells activate in response to IgE binding, which happens by way of an IgE receptor that they express on their surface. However, you want IgE to cause degranulation only whenever there is a real parasitic antigen present. So how do you prevent activation when an unbound IgE antibody happens to float near the receptor? By mandating cross-linking, of course. You see, basophils and mast cells will not activate in response to a single IgE binding. So, when a random floater IgE binds to the IgE receptor, there is no activation and no release of granules. However, when a worm or parasite is actually present, there is usually tons of IgE bound to a single antigen. This cross-linking of IgE in turn causes IgE receptors to aggregate on the surface of the granulocyte, and it is this closeness of IgE receptors that actually activates the cell. In other words, degranulation or activation only happens when an antigen brings a lot of IgE close together. Functionally, this happens because the degranulation signal only activates when IgE receptors aggregate. All of this helps to improve specificity of immune responses. Got that? Okay, so we've now talked about how IgE cross-linking causes activation and degranulation of mast cells and basophils. So what does all this degranulation even release? The answer's obvious. Just look at that history book. When the marine biologists here discovered the rare Y-shaped eel species, they had to look through the history books to see if anyone had mentioned it before. I mean, you can't say you've discovered a new species without going through the history, right? Anyway, the history here reminds me of histamine, the molecule released by basophils and mast cells upon activation of IgE. In other words, IgE cross-linking causes the release of histamine. All you need to know for now is that histamine is an inflammatory molecule that increases the permeability of our blood vessels, so white blood cells can leak out and fight infections. In a normal immune response, histamine protects against infection by inducing an inflammatory response. But this histamine release can also be problematic when the activation of basophils and mast cells happens by mistake. To understand what I mean, let's now turn back to our scientist. He seems to be having a severe allergic reaction to the eels. I mean, see the giant hives on his body? I guess this guy was always the bookish type and only just now discovered his allergy to eels and other seafood. Anyway, this allergic reaction should remind you of allergy and anaphylaxis, since IgE plays a major role in allergic responses. Remember when I said that cross-linking of IgE confers specificity? Well, sometimes IgE is not targeted against parasites, but instead incorrectly targeted against harmless antigens, including pollen, peanuts, or seafood, including eels. These harmless antigens, called allergens, bind IgE and induce the same cross-linking response that we saw earlier, causing activation of mast cells and basophils. This releases histamine and other immune mediators, causing the allergic response. The specific type of allergy mediated by IgE is so important that it actually has a name: Type 1 hypersensitivity reactions. We'll cover Type 1 hypersensitivity in a dedicated video, but for now, you should just remember that IgE directed against harmless allergens is responsible for producing allergic reactions. Phew, now we're done with IgE. Let's let our marine biologists finish researching their eels and recap what we've learned. Immunoglobulin E, or IgE for short, is a type of antibody responsible for mediating immune responses against parasitic worms. IgE can directly bind the parasite or activate other immune cells to produce a response. Importantly, cross-linking of IgE happens when multiple molecules of IgE bind the same antigen, and this clumping of IgE causes activation of basophils and mast cells. This eventually results in histamine release, which generates a local inflammatory response. While IgE normally targets parasitic antigens, it may incorrectly target harmless allergens, which explains its key role in allergic reactions. That's all for IgE. I'll see you in the next one.